Here is the biggest lie in blockchain privacy. You either have it or you don't. Every privacy chain author gives you a binary choice. Hide everything or show everything. Pick one. But that's not how real world works. In the real world, you show normally your ID to a bouncer, your medical records to a doctor, and your tax returns to a government, for example. Different people get different levels of access. Midnight is the first blockchain that actually gets this right. And today, I'm gonna break this down and explain that in detail. Let's set the stage. Right now, in blockchain, you have two extremes. On one end, full transparency, for example, Ethereum. Every transaction, every balance, every contract interaction, it's visible to anyone on the planet. Great for trust, terrible for privacy. You wouldn't post your bank statement, for example, on Twitter, but that's basically what you are doing on Ethereum. On the other hand, full anonymity, Monero, Zcash, for example, everything is hidden by default. Great for privacy, but here's a problem. Regulators can't see anything, auditors can't verify compliance, and enterprises, the companies with real money to spend, won't touch it because they can't prove they are following the rules, even if they are. So we've got this gap, the massive gap in the middle, where you need some privacy but also some transparency, where different parties need different levels of access to the same data. And until now, nobody had a good answer for that. Enter Midnight's model. They call it rational privacy, and it's built on a beautiful, simple idea. Every transaction supports three disclosure views. First, the public view. This is what anyone on the network can see. Basic metadata, the transaction happened, the proof is valid, the timestamp. Think of it like looking at the outside of an envelope. You know it exists, you know when it was sent, but you can't read the letter inside. Then, second, the auditor view. Now we are getting interesting. This is the compliance layer. Regulators, auditors, designated third parties, they see additional details, enough to verify the rules were followed, enough to confirm amounts are within legal limits, enough to say yes, this transaction is compliant without seeing the full picture. Third, the gut view, full access, complete visibility into every detail of the transaction. But here's the key. This is only available to explicitly trusted parties, the sender, the receiver, and whoever they have specifically authorized. This isn't just a nice idea, this is programmable. As a developer, when you write a compact in a smart contract in Compact at Midnight, you define what's public and what's not. You decide what goes in the public view and what the auditor sees and what stays fully private, for example. The disclosure model is baked into the contract logic, not bolted on after that fact, for example. Not managed by some admin dashboard, it's in the code itself, enforced by cryptography. Okay, so this all sounds great in theory, but how do you actually enforce three levels of visibility without trusting someone to manage the access? This is where serial knowledge proof come in, and this is the part that makes Midnight genuinely different. When you write a smart contract in Compact, that's Midnight contract language, the compiler generates something that is called secret circuits for your contract logic. These circuits define exactly what can be proven without revealing the underlying data. So when a transaction happens, here's the flow. A user first takes an action, the Compact contract processes it, a CK proof is generated. That proof mathematically guarantees three things simultaneously. First, the transaction is valid, the rules were followed. Then, the public view contains only what was designated as public, nothing leaks. And lastly, the auditor view reveals exactly what was designated for compliance, no more, no less. So nobody trusts anybody, the math does the work. A regulator can verify compliance without seeing private data. A user maintains privacy without breaking any rules, and everything is cryptographically probable. This is what smart compliance means. It's not we promise we're compliant, it's here's the mathematical proof and we are compliant, and go ahead, you can prove it by yourself. Now here's where some of you are thinking, okay, cool, CK proof for every transaction, but isn't that incredibly slow? Fair question. Generating CK proof is computationally expensive. If every transaction had to generate and verify a full proof on the L1 midnight, you will be waiting minutes, maybe longer. That's where NightStream comes in. NightStream is midnight L2 layer, and it's where the magic of performance happens. Here's how I understand it. All the heavy lifting, processing shielded nodes, handling nullifiers, encrypting transaction data happens on NightStream. It maintains its own complete state. All the CK proof generation happens here. But instead of posting every transaction to midnight L1, NightStream batches them. It aggregates the results and posts compressed diff to L1. Not the full state, just enough data to reconstruct everything if needed. Think of it like this. If the L1 is the permanent record, NightStream is the high-speed processing center, for example. It handles the volume, crunches the proof, and sends a summary back to base. This is what lets Midnight handle real throughputs. The AI agents in Midnight City, they are generating thousands of transactions. NightStream is batching, proving, and compressing all of that in real time. Alright, this is the part I'm most excited about, because Midnight doesn't just rely on CK proof. They have built this 3-layer security model where each layer covers the other's blind spots. Layer 1, TE, which means Trusted Execution Environment. Hardware level security. A TE oracle executes and attests each batch inside a tamper-proof hardware. The key insight here is speed. Nodes verify one signature from the TE instead of re-executing thousands of transactions. That's how you get instant finality. Layer 2, data availability on L1. This is the safety net. All the compressed diff from NightStream get posted to Midnight L1. Why? Because if the TE ever fails, hardware breaks, gets compromised, or anything else happens, anyone can reconstruct the full chain state from L1 data alone. You are never dependent on a single piece of hardware. Layer 3, CK proof. The privacy guarantee. Even if someone can see the data on L1, even if they compromise the TE, the zero knowledge proof ensures that private data stays always private. The proofs are mathematical. You can't reverse engineer the private inputs from the proof. Here's why this combination is so powerful. TE alone, fast, but you're trusting hardware. What if it breaks? Data availability alone, safe, but all data is exposed, no privacy. CK alone, private but slow, can't handle real throughput. So if we put all this together, TE gives you speed, data availability gives you safety, and CK gives you privacy. 3 layers, each covering the other's weaknesses, no single point of failure. Okay, let me give you the mental model that makes this click. Picture an armored truck. That's your TE. It moves value fast. The driver is verified through hardware credentials. You trust the truck because it's built to be tamper-proof. Now picture CCTV cameras recording the truck's entire route. That's your data availability layer. You don't check the footage every day, but if the truck ever gets hijacked, you recover everything from the recordings. Now picture sealed envelopes. Inside the truck, that's your CK proofs. Even if the driver, for example the TE, can't read what's inside those envelopes. The contracts are protected by math, not by the truck's armor. No single layer is enough alone. The truck can crash, the cameras can be ignored, the envelopes can be lost, but together, speed, safety, privacy, all 3 at the same time. That's Midnight architecture. Midnight Mainnet launches at the end of this month. That's not a sometime in 2027 promise. That's weeks away. Google Cloud is running nodes, Vodafone's, eToro, BlockDemon. These are companies that don't sign up for experiments. They sign up for infrastructure they believe will matter. And the use cases this unlocks are really massive. AI agents that can prove they follow compliance rules without exposing the data they processed. Think the healthcare, finance, legal, anywhere AI handles sensitive information. DeFi protocols that give regulators an auditor view without sacrificing user privacy. That's the difference between getting shut down and getting approved. Enterprise applications with selective disclosure. Show your partners what they need, hide what they don't, and prove everything cryptographically. This is privacy infrastructure for the real world. Not hide everything and hope nobody asks, but prove compliance, protect privacy, and let the math do the talking. If you're building anything that touches privacy, compliance, or AI agents on chain, Midnight is the stack to learn. We've got a build session coming up where we walk through an actual compact smart contract, CLI, and UI, full hands-on build. If you're building anything that touches privacy, compliance, or AI agents, we help teams with exactly this: architecture, integration, the whole stack. Links to everything in the description below. And if you want direct async access to the team, check out our memberships. Post your questions in the shared cohort room, get expert answers. It's the fastest way to get unstuck while you're building. Link below. See you in the next one.